Greetings, grade 4s. Welcome to another lesson of maths. All my budding mathematicians out there, let's get into today's lesson. The normal reminders at the start of the lesson. If you want to email me, you can email me. I am Mr. T or Mr. Travis. My students call me both. Just email me, grade4@worksheetcloud.com. And if you have any questions, if you have any questions. And after the lesson, click on the link above, do the worksheet just to make sure that you've got, because practice is how we make sure that we've established something and cement it into our brains, our working memory. Okay, next slide as normal is 10 mental arithmetic questions to get your brains working. I'm not going to give you any clues, but you've got 40 seconds to answer 10 questions. First, you need to make sure you're getting all of them right regularly, and after that, make sure you're getting them right quicker and quicker. Here we go. 40 seconds start now. And just like that, 40 seconds are gone. There are numbers next to these questions. They're just a little faint, but it doesn't really matter. All right, so in all of these questions, I'm crossing a 10 barrier. In other words, I'm going from above 10 to below 10. It's one of the areas that people sometimes get wrong, but let's go through them. 15 minus 8 is 7. 16 minus 9 is 7. 15 minus 7 is 8. 16 minus 7 is 9. 13 minus 6 is 7. 11 minus 8 is 3. 13 minus 8 is 5. 11 minus 5 is 6. 14 minus 6 is 8. 14 minus 8 is 6. If you missed any of those, just rewind the video, watch it again, and mark it. As long as you're improving, either getting more and more right or getting them right quicker and quicker, then you're doing well. So, in a previous lesson, or in another lesson, we looked at measurement of length, and today we're going to look at measurement of capacity. You may not have heard that word if you haven't done it yet this year, although I'm pretty sure the idea of capacity is not going to be new to you. So our goal is, first of all, to understand what capacity is, then know the common units of capacity, the ones we use all the time, and finally be able to convert units of capacity, so changing from one to the other. So what is capacity? Simply put, it's how much something can hold. So where I found sometimes grade 4 struggle a little bit is the difference between volume, which is how much space something takes up, and capacity, which is how much, you can think of it as how much liquid something can hold, although it's also how much air something can hold, and so on. Okay, so if you look at those little blocks that say FAQ, which stands for frequently asked questions, but if you look at those blocks there, they're solid. They take up space, but they can't hold anything inside them. So they have a volume, but they have no capacity. If you look at the jug can hold something, and the amount of something they can hold is its capacity. Now, it is possible for something to have capacity and volume. For example, that jug does have a volume, and the volume of the jug is how much space the actual jug takes up, not including what it can hold, but just how much space that glass or plastic takes up. So a box is another example that's quite a good one to think about. If a box is there, and let's think of a cardboard box, you can hold something inside it. I wouldn't necessarily put a liquid inside it. It'll make the cardboard soggy and it'll run out, but it has a capacity. That's how much you can put inside it. And it also has a volume because the box takes up space. So it's possible for something to have both capacity and volume. It's possible for something to just have volume, but it can't just have capacity. So it has to have an outside in order to hold something, and so because of that, it will have a volume of sorts. All right, but the main thing for this lesson is we're looking at capacity, which is how much something can hold, how much liquid something can hold. Okay, so I'm going to jump back to another lesson, or just recap this, which was how we remembered length and the different units of length that we used. So we had kilometers, which we used, meters we used, centimeters and millimeters, but there were those other three that do exist, but we just don't use them very commonly. Perhaps scientists use them more. And we remembered them using that mnemonic, which is King Henry's daughters make delicious caramel muffins. Now you might be asking yourself, why on earth, Mr. Travis, are you teaching us about this or recapping length when we're actually doing capacity? Well, simply put, if you've understood how to convert with meters or with length, then doing it with liters is going to be super simple for you. So first of all, instead of meter, we have liter, which is a small l, that's its symbol. The other one we normally use is milliliters, which I'm sure you've come across, like on the back of a cool drink, it says it's 500 milliliters or 300 or 250. So that's milliliters. That's the other one we normally use. Sometimes if you've got a lot of water, we talk about kiloliters. So if you ever read your parents' rates bill, the amount of water that your household uses in a month is measured in kiloliters. But actually, we only really focus on two of these, and the ones you'll come up with or come across quite often are liters and milliliters. All right, so these are the ones, and we can use the similar mnemonic. So I just changed the middle one from make to love. So King Henry's daughters love delicious caramel muffins, and it works exactly the same. So when you're going up the list, you take away zeros. When you're going down the list, you add zeros. Put zeros on, not add zeros. So King Henry's daughters love delicious crunch caramel muffins. So it's kiloliters, hectoliters, decaliters, liters, deciliters, centiliters, and milliliters. I have occasionally seen this one used, centiliters. I don't know why, but I've seen it used on a few different bottles. Okay, so there are some other measurements, units of measurements that you may come across in your in daily life, especially if you're somebody who enjoys being in the kitchen and cooking. So you may come across a measurement of how many cups of water you should put in. A cup is a specific measurement. A cup is 250 milliliters, and half a cup is 125 milliliters, and so on. A tablespoon is 30 milliliters. A teaspoon is 5 milliliters, and you get various ones like that, those measuring cups and jugs that you can use. You may have, if you read cartoons and things or American stuff, you may come across the word gallon, which is also a unit of capacity. It's a unit of measurement for how much liquid something is, but that's not a metric unit, and it's not something you'll be tested on at school, so you don't need to worry about it. Same with fluid ounces, another measurement you may come across in a cookbook, but it's also not something that you need to know about. My suggestion is, if you ever come across gallons or fluid ounces, is you just go to Google and you search gallons, you type the word gallons in, and it'll finish for you in liters or milliliters and so on, or fluid ounces in, and it'll be able to convert for you very quickly. You might not even have to finish typing, it'll do it that quickly. So let's go and do some conversions, and once we've done some conversions, I'll show you maybe how we might practically apply some of these. So first thing we're going to do is see if you can remember the mnemonic, the poem or sentence that we say in order to remember the various units of capacity. If you make up your own one of these, that's really cool. So King Henry's daughters love delicious caramel muffins. So that's kiloliters, hectoliters, decaliters, liters, deciliters, centiliters, and milliliters. All of them are lowercase letters or small letters except for the D, and that's because we have two D's, so we need to differentiate. So deca is the bigger, it gets the bigger letter, and deci is the smaller, it gets the smaller letter. All right, so again, if we're moving this way, we're going from a big unit to a small unit, we put zeros on. And if we're going from a small unit to a big unit, we remove zeros. And as I mentioned when we did measurement or length, please don't say we add zeros or take away zeros, because mathematically that's not true. Because if I've got 1 and I take away 0, it's still 1. And if I've got 1 and I add a 0, it's still actually just 1. So although I know what you mean, and your teacher will too, it's mathematically not a true statement. And I get fussy about mathematical statements being true. Okay, let's put down some examples and practice, but just with the units that we normally do. So I'm going to look at converting between liters, milliliters, and kiloliters. The other 4 are not ones that are regularly used, especially not at grade 4 age. So I've used a cursive L in these just to make it look a little bit different from a 1, because sometimes it's not so easy to see whether it's a 1 or a cursive L. So we're going from kiloliters to liters. So we're going this way. We're going to put zeros on. We're going 1, 2, 3 jumps. We put 3 zeros on, so we get 5,000 liters. From kiloliters down to milliliters is 1, 2, 3, 4, 5, 6. So we put on 6 zeros. So we had 90, and now we need another 6 zeros. So 3 and 3. So 90 kiloliters is equal to 90 million milliliters. And again, this one we're going from kiloliters to milliliters. It's again 6 jumps, so it's got to be 6 zeros. So 3 kiloliters is equal to 3 million milliliters. Now we're going from liters down to milliliters. That's 3 jumps, so we're going to put 3 zeros on the end. So 6 liters is equal to 6,000 milliliters. The next one, we're going from liters to milliliters again. So we're going 1, 2, 3. We already had 80 there. We're going to put another 3 zeros on, 80,000 milliliters. And finally, the big one, we're going to go from kiloliters down to millimeters. By now, you should realize it's 6 jumps. So 3, 5, we put 6 zeros on the end. So, oh, sorry, we were only going to liters. So only down to liters. So that was 3 jumps. And so we get 35,000 liters. So 35 kiloliters is equal to 35,000 liters. Okay, let's have a look at some going in the other direction. So we are going in our first example from milliliters to liters. That's going this way. So we're going to remove zeros, and we are going to remove 1, 2, 3 zeros. 1, 2, 3. So we're left with 60 liters. So 60,000 milliliters, 60 liters. When we go from milliliters to kiloliters, that's 1, 2, 3, 4, 5, 6. We take away 6 zeros. So we're left with 5 kiloliters. So 5 million milliliters is equal to 5 kiloliters. The same one for the next one. It's still going to be 6 jumps. So we take away 6 zeros. And we're left with 90 kiloliters. To go from liters, from liters up to kiloliters means we start at liters and we go up to kiloliters. That's 1, 2, 3. Take away 3 zeros. And we're left with 4 kiloliters. Again, from liters to kiloliters, still 3 jumps, so we're left with 350 kiloliters. Going from milliliters to liters, so milliliters, 1, 2, 3 jumps, 2, 3 zeros off, and we get 80 liters. Right, I wanted to quickly do a little bit of an extension. Let me put that on quickly. So I've just got these two down at the bottom. I know you haven't done decimals yet, and you're not required to, but you might come across something like this before you actually do decimals, and that's where we've got 4,5, something like this, 4,5 liters, which means 4.5 liters, and we're going to kiloliters. So if we look at where we are, we're starting from liters, and we're going up to kiloliters, which means we need to remove zeros. Oh, hang on, I've made that. Oh, no, I'm going the wrong way. That's right, I'm starting there and I'm going down to there. So I've got to add on 3 zeros. So what am I going to do with this? Well, quite simply, before we start adding the zeros, we need to move our comma to the end. But moving the comma is the same as adding a 0. So that's 1 to move it there, which would make it 45. And now I still need to add another 2 zeros. So the first jump from there to there was moving the comma from in front of the 5 to after the 5, and then I add 2 zeros, all right, which is the same as moving the comma down a little bit. So my answer then is 4,500 liters. Remember, this is extension. You're not necessarily needing to know this just yet. I just thought I would show you because it does extend into decimals, which is quite nice and handy. Looking at going the other way, going from liters to kiloliters, where we remove zeros. So I need to remove 3. I've removed 1 and not 2. Now what am I going to do? So instead of removing the 4, I'm going to move to there and I'm going to put a comma. So then my answer is 3,4 kiloliters. If you don't get that yet, please don't stress yourself. The ones that you're going to get in grade 4 are all going to be nice ones where you can either take away a 0 or you can put on a 0. So all you've got to remember is these things. You've got to remember all of those. So use your mnemonic. So King Henry's daughters love delicious caramel muffins. You've got to remember that if you're going from a small unit to a big unit, you take away zeros. You've got to remember that if you go from big to small, you put on zeros. And if you can do that, then you're not going to have any problems with this. Okay, what we're going to do now is have a look at some practical examples with word problems of how you might be asked about capacity. So here's an example. You have a lemonade recipe. This is my lemonade recipe. I've never made lemonade. I just needed to make up something that had different quantities in it so that we could do maths with it. Anyway, there's a liter of water, 100 ml of lemon juice, 500 ml of soda water, 50 ml of orange juice. I don't know why. Just needed something else. So how much lemonade is there altogether? So we're assuming that that's all the ingredients and that there's no actual lemons or anything else that goes in. So that's all that goes in, and we want to know how much there is. So the first thing we've got to understand when we're adding different things is we have to make the units the same, the units of capacity the same before we add them together. So the easiest thing to do over here would be to change our liters into milliliters before we add that up. So we've got 1 liter of water, and we want to make it into milliliters so it matches the other measurements. So we're going from liters to milliliters. That's going 1, 2, 3 down. So we're putting zeros on. So 1 liter is equivalent of 1,000 milliliters. So now what we need to do is to add together our different things, which I'm going to do. Let me slide it this way. So I have 1,000, and I have 100, and I have 500, and I have 50. That's all milliliters. I need to add that together. So I'm going to add my zeros, and I get 0. The next column I get 5, the next column I get 6, and the next column I get 1. So then my answer is how much lemonade there is 1,650 milliliters. Right, I would ask you to put that in a word sentence. So you have 1,650 milliliters of of lemonade, but I'm not going to do that for now. Okay, that, if you're good with decimals or conversions, is the same as 1,65 liters. Okay, the next one is I've got a jug that holds 2 liters of water. If I pour 280 ml into a glass, how much is left in the jug. So first of all, I've got two different units of measurement here. I've got liters and milliliters. I need to make them the same to work with them. At this stage of your mathematical progress, I would say it's going to be easier to make them to both into into milliliters. So let's convert that. So we're going 3 jumps down. So we're going to add 3 zeros on. So 2 liters is 2000 milliliters. All right, so if I imagine I've got a jug, I'm going to draw it over here. No, actually, I'm going to draw it underneath. I have a beautiful jug with a spout. Okay, so maths is something I'm good at, drawing is not. All right, there's my jug, and it's full, which is 2000, and then I pour 280 milliliters into this beautiful glass over here. So the water level has gone down, lemonade level has gone down by a certain amount. So in other words, it's a subtraction problem, it's a minus problem. So I've got 2000, I'm going to minus 280, and let's do that quickly to find out how much lemonade or whatever is left in the jug. So 0 minus 0 is 0, 0 minus 8 I can't do, so I need to borrow, but there's none next door. I have to go 2 doors down, so that becomes a 1, this becomes a 10, it crosses out and becomes a 9, and that becomes a 1. So 10 minus 8 is 2, 9 minus 2 is 7, 1 minus nothing is 1. So I have 1720 milliliters left in the jug. Right. We've got time for one more. So let's say I have 2 liters of cool drink and I have a glass that holds 250 ml. How many times can I fill the glass from the bottle until I've got nothing left? So how many glasses are there in the 2 liter bottle? Well, again, I have two forms of measurement. I've got liters and milliliters, and I need to make them the same. So doing that very simply is 3 jumps, putting 3 zeros on, 2000 milliliters. So now I've got to figure out how many times does 250 go into 2000. Now, that would be a little bit of long division, but perhaps we can work that out quite simply just by doing some workings at the bottom. So that's what we're trying to do. 2000 divided by 250. So one of the things we can do with zeros is to just, because we've got a 0 on the end of both of them, we can take away that 0. And when we do 200 divided by 25, we're still going to get the same answer as if we do 2000 divided by 250. So how am I going to go about this? Well, I think possibly at your age, the easiest thing to do is going to be to keep adding until we get to the right amount. So I'm going to add 250s, let's go 225s until I get to 200. So 225 plus 25 gives me 50, plus 25 gives me 75, plus 25 gets me 100. I'm going to stop there and say, isn't 100 like half of 200? So however many I needed to get to 100, I'm going to need twice as many to get to 200. Well, I used 1, 2, 3, 4. So it took me 4 to get to 100, which means it'll take me 8 to get to 200, which is in fact the answer. So the answer is that your bottle has 8 glasses of cool drink in it. All right, so I can fill my fill my glass 8 times. Right, so the most important thing to note with looking at capacity is that you're able to convert particularly between liters and milliliters. That's the one that's going to come up the most often. The other ones are maybe kiloliters, but mostly it's going to be liters and milliliters. So being able to convert between those. And when you get a problem that has both, before you start working with the numbers, you need to make sure that they're both liters or they're both milliliters. So you've got to make sure you're using just one kind of unit when you get down to the maths of your problems. All right, well, that's all we have for today. That's capacity. So if you've understood the units of length and the units of capacity, then there is still something else that's going to be easy for you as well, which we're going to do in the future. Grade 4s, if you want to email me, it's grade4@worksheetcloud.com. Do that worksheet by clicking on the link, just to make sure that you've got this, that you're able to do the conversions, that you're able to solve this kind of problem. I look forward to seeing you again, grade 4s. Have a great day.